children, how are you doing? I hope you all are doing fine, and let's start the new topic, light. And what's the aim to learn this? Aim to learn this is we are going to learn about light, laws of reflection, types of reflection, formation of multiple images, and we are going to learn about kaleidoscope, refraction of light, the human eye, care of eyes, reflection of light, reflection by a plane mirror, formation of images by a plane mirror, and periscope, dispersion of light, defects of vision, the Braille system. Now let's start the chapter. इतना सब आप जानने वाले हैं. इन सब के बारे में जानने के लिए let's start the chapter with warm up. There are some pictures given below. Sort out the reflective and non-reflective materials, surfaces among them by writing R for reflective and NR for non-reflective surfaces. So let's start with the light now. Light is a form of energy which causes in us the sensation of vision. When light falls on an object, it becomes visible. We have learned that objects like the sun, the stars, a burning candle, a glowing tube light, a lighted electric bulb which give out their own light are called luminous objects. Do you know the property of light by which it travels in straight lines is called rectilinear propagation of light. Objects that do not emit light on their own like chair, table, bird, plant, etc. are called non-luminous objects. Now let's read about refraction of light. The process of sending back the light rays which fall on the surface of an object is called reflection of light. When we stand in front of a window pane, we sometimes see our own image in the glass along with the objects which we see through it. This is because some light is being reflected by the glass pane and some light passes through it. Some light is also being absorbed by the glass. Some terms related to reflection. Incident ray. A ray of light falling on a reflecting surface such as mirror is called the incident ray, and in figure AO is the incident ray. Point of incidence. The point at which the incident ray strikes the reflecting surface is called the point of incidence. O shows the point of incidence in figure. Reflected ray, the ray of light that is reflected from the reflecting surface at the point of incidence is called the reflecting ray, and OB is the reflected ray in figure. Normal. The normal is a line drawn at the right angle perpendicular to the mirror surface at the point of incidence. The dotted line ON is the normal to the mirror surface MM at the point of incidence O. Now angle of incidence. The angle between the incident ray and the normal is called the angle of incidence. I shows the angle of incidence for the incident ray IAO. Angle of reflection. The angle between the reflected ray and normal is the angle of reflection. R shows the angle of reflection for the reflected ray OB. Do you know the angle 90 for example, the angle which is incident ray makes with the plane reflecting surface is called glancing angle. Activity time. Aim is to study the reflection of light. Materials required: white sheet of paper, drawing board, table, comb. Method is: fix a white sheet of paper on a table, take a comb and close all its openings except one in the middle. Use a strip of black paper for covering the openings except the one in the middle. Hold the comb perpendicular to the sheet of paper. From one side throw light from a torch on the open part of the comb. Place a strip of plane more in the plane mirror in the path of light. Then observation will be: you will see a ray of light along the paper on the other side of comb. Laws of reflection. When a ray of light gets reflected from a smooth surface, it obeys certain laws. These are called laws of reflection. First law of reflection: the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. It means AO, ON and OB are in the same plane. Second law of reflection: the angle of incidence is always equal to the angle of reflection. Yes, that is, for example, angle I and angle R. Angle I is equal to angle R. The laws of reflection apply to the all reflecting surfaces, whether plane or curved. Do you know, if the incident ray falls on a plane mirror along the normal, for example at 90 degree, the reflected ray will travel back along the same path. Here both the angles of incidence and the angle of reflection are at 0 degree. For example, angle I is at 0 degree and angle R is at 0 degree. Okay. Reflection by a plane mirror. Any smooth polished surface which can return the rays of light at the same angle is called a mirror. A plane mirror is used by us every day at our home for looking at our own image. This is because most of the light falling on a mirror is reflected by it. Any highly polished metal surface and even still water act like a mirror. Types of reflection. When a ray of light falls on a reflecting surface, it gets reflected, and the amount and the direction of light reflected depends on the nature of the surface. Depending upon the nature of reflecting surface, there are two types of reflections. One is regular, another is irregular or diffuse reflection. So, the number one we are going to read regular reflection. When a ray of light falls on a smooth reflecting surface, for example a mirror, it gets reflected along a particular direction. That is why a smooth surface gives a sharp and clear image. Reflection of light from a smooth mirror is called a regular refraction. Irregular or diffuse reflection. When light's rays fall on an irregular or rough reflecting surface, they get reflected in different directions. As a result, the image is not sharp and clear. This type of reflection is called irregular or diffused reflection. Real and virtual image. Now let's read about this. Two types of images are formed by a mirror. These are real image or virtual image. Real image, the image which can be obtained on a screen, is called a real image. It is formed when the light rays after reflection or refraction actually intersect each other. The image of actors on the screen in a cinema hall is an example of real image. Virtual image, the image which cannot be obtained on a screen, is called a virtual image. It is formed when the light rays after reflection or refraction do not actually intersect each other, but they appear to diverge from it. The image of our face in a plane mirror is an example of virtual image. Formation of images by a plane mirror. You have already studied the characteristics features of the image formed by plane mirror. Let us recall them. The image formed by a plane mirror is virtual. The image is laterally inverted. The image formed in the mirror is erect. The image formed by a plane mirror is of the same size as the object. The distance of the image from the mirror is equal to that of the object from the mirror. When an object is a point source of light, let us consider a point object O placed in front of a plane mirror consider two rays of light OA and OB falling on the mirror at points A and B respectively. These rays, after suffering reflection, get reflected along AC and BD respectively. The reflected rays appears to come from point I. The point I is the image of point object O. Differences between real and virtual images. Real image, it can be taken on the screen, and virtual cannot be taken on the screen. Real image is always inverted and virtual is always erect but laterally inverted. Real rays of image, in real images the rays of light after reflection or refraction meet at point, and in virtual images the rays of light after reflection or refraction appear to meet at a point. Number 2, image of an extended object. Consider AB, a small pencil, as an extended object placed in a front of a plane mirror. We shall consider the formation of images of points A and B, which are at the ends of an extended object. A divergent beam starting from point A after reflection from a plane mirror appears to diverge from point A. Similarly, a divergent beam starting from point B after reflection from a plane mirror appears to diverge from point B. Thus, A1B1 is the virtual image of extended object AB, which is literally inverted and is formed as far behind the plane mirror as the object is in front of it. Now let's read about formation of multiple images. When two plane mirrors are held at same angle to one another and an object is placed in between them, then multiple images are formed. Depending upon the angle between them, we will consider three cases. When two plane mirrors take an angle of 90 degrees with each other, when two plane mirrors make an angle of 60 degrees with each other, when two plane mirrors are facing one another. It is observed that if the angle between the mirrors is Q, number of images is equal to 360 degree by Q is minus 1. Thus, if the mirrors are at right angles, you will see 360 degree by 90 degree minus 1 is equal to 4 minus 1 is equal to 3 images. If the angle between the mirrors is 60 degree, 5 images can be seen. 360 degree by 60 degree minus 1 is equal to 6 minus 1, 5 images. If the angle between the mirrors is 30 degree, 11 images are formed. 360 degree by 30 degree minus 1 is equal to 12 minus 1 is equal to 11 images. When two mirrors are kept parallel to each other, angle is equal to 0 degree and infinite number of images can be seen. The images get fainter as their distance from the mirror increases. When the mirrors are placed at the right angles to each other. When an object is placed in front of two plane mirrors placed at right angles to each other, three images are formed as shown in the figure. The image 1, image I1 of the object O is due to the mirror 1. The image I2 of the object O is due to the mirror 2. The third image I3 may be considered to be the image of I1 in the image of mirror 2 or the image I2 in the image of mirror 1. Thus, the image I3 is an overlap of two images, say I3 and I opposite of 3. Thus, the image I3 is brighter than both I1 and I2. Now, when two mirrors are placed parallel to each other, let us consider an object O placed in between the two plane mirrors held parallel to each other. The image of the object in the mirror M2 is formed I1 as far behind the mirror as the object in front of it. The image I1 acts as object the mirror M1 and its image is formed at I2. The image I2 then acts the object the mirror M2 and the corresponding image is formed at I3. This process of image formation continues and infinite numbers of images are formed in the mirrors. Kaleidoscope. Kaleidoscope is an optical instrument which operates on the principle of multiple reflections. It is made by setting usually three mirror strips at 60 degree angles to each other to form a triangle. Between the strips are a few pieces of colored glass held between a translucent bottom and a transparent glass plate. The whole arrangement is kept in a cupboard tube with a hole to watch at the other end. On looking and rotating the kaleidoscope tube, we see very beautiful colored patterns due to multiple refraction of light from the three mirrors. Let's do one activity. Aim to make a kaleidoscope and materials required: three plane mirror strips, adhesive tape, colorful beads and a cardboard. Procedure is fix the mirror strips by tape in the shape of a prism so that are at an angle of 60 degree to each other. Note that the shiny or the reflected face should be facing inwards. Fix them in a circular cardboard tube of a thick chart paper. Cover both the open ends of a cardboard tube with transparent sheet by tape. Place some colorful beads at one end on the transparent sheet and cover it by tracing paper. Hold the kaleidoscope towards light and rotate it. Observation is enjoy what you observe and share your experience with the class. Now let's read about periscope. It is another instrument which is based on the principle of multiple reflections. A periscope is a long tubular device through which a person can see objects that are out of direct line of sight. This instrument consists of two plane mirrors that are placed at a vertical angle of 45 degrees. In the kaleidoscope, the mirrors are placed touching each other, but in a periscope, the mirrors are kept at a distance from each other. The image formed by the mirror acts as the objects of the other mirror. Some of the uses of periscope are given below. A periscope is used to view things at a different level, for example, above the heads of a crowd. A periscope is used by soldiers sitting in a trench or bunker to observe the enemy's activities outside over the ground. A periscope is used by a navy officer sitting in a submarine to see ships over the surface of water in the sea, even though the submarine itself may be submerged underwater. Refraction of light. Diffraction occurs because light travels at different speeds through different transparent media. Light travels at 3 into 10 by 8 in vacuum or air, but when it passes through a medium like glass or water, it slows down. Due to change in speed, its path changes and so it bends. The phenomena of bending of light when it travels from the one medium to another is called refraction of light. Dispersion of light. In 1665, Sir Isaac Newton discovered through his experiment, with his experiments with glass prisms, that white light, say sunlight, is composed of 7 columns, that is violet, indigo, blue, green, yellow, orange and red. So all these colors. He found that when white light is passed through a prism, it splits up into 7 colors and is called dispersion of light, and the band of 7 colors thus obtained is called spectrum of white light. Cause of dispersion: when the white light passes through a prism, its various colors deviate, bend by different amounts. This deviation is maximum for violet light and minimum for red light. Due to this difference in deviation, the various colors of light emerge out of the prism in the form of spectrum. The rainbow is a very common example of dispersion of light in nature. Tiny droplets of water suspended in air acts as prism. These droplets splits the white light just like a prism and we see the rainbow. The human eye. The human eye is a very complex structure and each eyeball is set in a socket which is a protective cavity in the skull. The eyelids prevent outside particles from entering the eye, and human eye is spherical in shape and it functions like a camera. Therefore, the following main parts of the eye: pupil, it is the hole located at the center of iris through which light enters the eyes. Iris, it is the colored part of the eye and consists of muscles. It controls the amount of light that enters through the pupil, increasing or decreasing the size of the pupil. Sclera, it is the white part of the eye. It is filled with a clear, watery fluid. Cornea, it is the thin transparent tissue which covers the front of the eye. Retina, it is like a screen behind the eyeball. The image of the object that we see falls on the retina. The retina has light sensitive cells called rods and cones. When light falls on these rods and cones, they generate electric impulses that are sent to the brain by the optic nerve, and the brain then interprets what the eye has seen. Lens, it is a transparent tissue found between the pupil and the retina. The light which enters through the pupil is brought to focus by the lens. Ciliary muscles hold the lens in place. Optic nerve, it is a big bundle of nerves starting from brain and then entering in the eyeball from the back. They carry signals to the brain. And now blind spot. Blind spot is a region on the retina that does not have any rods and cones, so the images falling on this part of the retina cannot be seen. Persistence of vision. Now we are going to read about this. Persistence of vision. Human eyes work just like a camera, and if our eyes look at an object, that sensation of it remains in front of our eyes for 1/16th of a second. This phenomena is called persistence of vision. Animation works on the phenomena of persistence of vision. Illustrations are made on pages which are called frames, and each frame is flashed on the screen for a very short period of time and replaced by a next sequence of frames. Due to persistence of vision, our eyes create an optical illusion which seems as if the object is in motion. Power of accommodation. The ability of the eye to adjust itself to see objects at different distances clearly is called the power of accommodation. Your eyes is a natural lens fixed in its place through muscles. This lens has power to change its focal length, and it is because of this that you can see clearly nearby as well as distant objects. In a normal eye, the power of accommodation stops when an object is at a distance of about 25 cm from the eye. If the object is brought closer than 25 cm, the image formed on the retina is not sharp and the object appears blurred. The least distance at which the eye can clearly see an object is called the near point, or the least distance of distinct vision. The far point of the eye is maximum distance to which the eye can see. For a normal eye, it is infinity. Defects of vision. Age, nutritional deficiency, genetic factors can cause defects of vision. An eye whose ciliary muscles cannot alter the focal length of crystalline lens properly, such that it is unable to see clearly either nearer objects or far off objects for both, is called defective eye. Some of defects of eyes are as follows. Short-sightedness or myopia. A person suffering from this defect to vision can see nearby objects clearly but cannot see distant object clearly. In a myopic eye, the image of the distant object is formed in front of the retina and not on the retina. This defect of vision can be corrected by using concave lens of appropriate focal length. And number 2, long-sightedness or hypermetropia. A person suffering from this defect of vision can see distant objects clearly but cannot see nearby objects clearly. In a hypermetropic eye, the image of nearby object is formed behind the retina and not on the retina. This defect of vision can be corrected by using convex lens of appropriate focal length. This defect can be corrected by using a convex lens. This defect is also known as far-sightedness. Cataract, another defect which comes with age, is when the eye lens becomes foggy due to regular wear and tear for so many years. If this continues, a new ailment arises which is known as cataract. Cataract is a major cause of vision loss in the people who are above 40 years and is the principal cause of blindness in the world. So, it is advisable for a person suffering from cataract to undergo a surgery as soon as the symptom like blurred vision persist and the cataract matures. Care of eyes. Some simple precautions that can help to keep them safe area as follows. Protect eyes from the extreme sunlight and glare of bright light and from the dust and husk. While reading, keep the reading material at a distance of about 20 to 30 cm from the eyes. Raise your eyes from time to time while reading, watching TV, etc. Do not watch television for long hours, particularly in a completely dark room. Never rub your eyes if any small particle or dust enters into your eyes. Wash your eyes with clean water. If condition does not improve, go to a doctor. Wash your eyes frequently with clean water. Lack of vitamin A in foodstuff is responsible for many eye troubles. Most common amongst them is blindness. One should therefore include in the diet that components which have vitamin A, raw carrots, broccoli and green vegetables such as spinach yani palak, methi and cod liver oil and rich in vitamin A. Egg, milk, curd, paneer, butter, ghee and fruits such as papaya, banana, mango, apple, dates, etc. also contain plenty of vitamin A. The Braille system. The Braille system is a method of writing for the blind. Blind people cannot see in the absence of the power of vision. The visually challenged people take the help of other senses such as touch, smell, taste and hearing to sense things around them. To enable blind people to study, Louis Braille himself, a blind person, created a script in 1834 of raised dots representing letters of alphabet, numbers and punctuation marks. This system later came to be known as Braille system, and the Braille system is a universally accepted resources used by visually challenged people. This system of letters, numbers and punctuation marks consist of 6 raised points or dots used in 63 possible combinations. Every character in a Braille code is based on an arrangement of 1 to 6 raised dots, with each dot having numbered position in the Braille cell. The table given here indicates the dots are arranged in the Braille cell for each letter of the alphabet. Braille numbers are formed using the first 10 letters of the alphabet A to J and a special number sign comprising of dots 3, 4, 5, 6. In 1980s, Braille computer software was developed, and additional aids include voice recognition software, optical scanner and special computer keyboards. These devices can input, output and translate documents from Braille. Letters 2. You have to write 1 or 2 words for all these questions in answers. Okay? आपको आंसर करना है 1 या 2 words में. Okay, another opportunities to recall the information for this chapter through revision time. Light is a form of energy which enables us to see different objects. The bouncing back of light from the surface with a change of angle is called reflection of light. Reflection of light happens from all surfaces. Angle of incidence is always equal to the angle of reflection. The incident ray, the reflected ray and the normal lie in the same plane. Reflection is of 2 types, regular reflection and irregular reflection. Kaleidoscope and periscope works on the principle of multiple refractions in inclined mirrors. The splitting of white light into 7 colors is called dispersion of light. The human eye is a wonderful optical instrument that works like a camera. Human eye consists of cornea, iris and pupil, lens, retina, optical nerve, etc. Myopia and hypermetropia are the 2 major defects of vision. A normal eye can see nearby and distant objects clearly. Visually challenged people can read and write using the Braille system. Now it's your turn. Exercise you have to do. आप प्रैक्टिस करेंगे एक्सरसाइज के थ्रू. एज यूजुअल आपको OMR शीट में करेक्ट ऑप्शन को डार्कन करना है. फिल इन द ब्लैंक्स. इस जो ब्लैंक फिल आपको करना है वो आपको हेल्प लेना है. चैप्टर में से एक वर्ड चूज कीजिए, करेक्ट वर्ड. स्टेटमेंट्स को आपने ट्रू और फॉल्स में चेंज करना है. आपको अगर स्टेटमेंट सही लगती है तो ट्रू T लिखिए, अगर गलत है आपके चैप्टर के अकॉर्डिंग तो आप F मार्क कीजिए. वेरी शॉर्ट एंड लॉन्ग आंसर्स क्वेश्चंस को आपको अपनी नोटबुक में आंसर्स को लिखना है. वेरी शॉर्ट को 3-4 लाइंस में, शॉर्ट आंसर्स को आपको 5-6 लाइंस में और लॉन्ग आंसर्स को आप डिस्क्राइब करिए डिटेल में. एक्टिविटी टाइम है. आपको लाइट के बारे में एक्टिविटी दी गई है, आप इसे रीड करें और ट्राई टू डू दिस. एंड होमवर्क इज बच्चों, मीट एन आई स्पेशलिस्ट, लेट योर आई साइट चेक्ड एंड डिस्कस हाउ टू टेक केयर ऑफ eyes. And please take care of your eyes क्योंकि eyes हमारे लिए बहुत important है. And have fun बच्चों, enjoy. What they call